Okay, here we have one problem. Example, now it is 11.3. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohm? Then one more question is there. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm? Okay, here given the two resistance values. One is having what is that? 1200 ohm, and other one is having 100 ohm. Okay, and we have to find the current value. Okay, already you know that if resistance value is more, the flow of electric charge is less, and it has lower current values. Yes or no? Now you see, how do we calculate this? Here we have the voltage is there, right? Resistance is there. Then we need to find the current. Okay, which formula gives the relation between the current, voltage, and resistance? That is Ohm's law. Okay, that is what is the value? That is what is the formula? I equal to V by R, where I is the current value, V is the voltage, and R is the resistance. Use this formula and find out the current value. Do it here. Please do it. Use the voltage value is 220 and resistance value is 1200, and find the current value. And one more here, uh, use the source value 220 and resistance value 100 ohm. In second case, what is the current value? In which case the current value is more? Just find out here. Okay, just pause the video and do it. So do it. And list here, resistance value is how much in the first case? 1200 ohm, right? And voltage value is 220 volts. And how do you find the current? Current value is I equal to V by R. So okay, what is the V value? V value is 220 by R value is 1200 ohms. Okay, when you calculate this, 22 by 120, so it will give 22 by 120. So you just check the value how much it is, right? So similarly, you find the next question B. In the question B, they given that the current will an electric heater coil draw from a 220 volt source if the resistance of the heater is 100 ohm. What is the voltage source? Battery source is 220 volt source. It is right. Then how much resistance is there for a heater coil? That is resistant heater coil is 100 ohm. Okay. Then find the current value. So we can find this I equal to V by R. So V is 220 and R value is 100, 0 cancel, then this is equal to 2.2 amperes. Okay, and it is 22 is there, so you do, that is how much? 2 11 times and 2 6 times, 11 by 60. Find out this, let us assume this is a 10 by 60. Okay, 0 cancel, and 1 by 6, and 1 by 6 means 0 point, approximately I am doing like this, so 40, 6 6 36, around 0.16 ampere it will come. Okay, around 0.16 ampere it will come. So just do it and find the answer here. 0.16, around 0.16 or 0.2 it will come, right? So 11 by 60, just I assumed as 10 by 60, so 0 cancel, so 1 by 6. So 1 by 6, how we can calculate? Okay, so you put point here, 0, 6 1 is 6, this is 40, 6 how many times? 6 6 are 36, again it will come 40. That means around it will come as a 0.16 or 0.17. Okay, so approximately it is equal to 0.17 ampere, and it is 2.2 ampere. Now you see, just you compare these both cases, and now you see the electric bulb has the resistance value is 1200 ohm, and which has the low current value 0.17 ampere. Means the material which has a more resistance value, and it has very low current value, that is 0.17 ampere, right? Now whereas in case of electric heater which offers the 100 ohm resistance, means resistance value is low compared to this, here 1200 is there, but here 100 is there. Okay, and both are connected to the same source, same battery, same source, right? 220 volt source. And now you see 220 by 100, it will give 2.2 amperes. When resistivity value decreases, current value increases. Okay, it is reciprocal. Resistance is inversely proportional to current. When resistance value is more, current value is less. When resistance value is less, current value is more. Okay, move on to the next one. Here one more question we have here. What is that? The potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 amperes from the source, what current will the heater draw if the potential difference is increased to 120 volts? Okay, that means already you observe when voltage increases, current value also increases. Means sometimes we observed in our home also when suddenly the light becomes very bright. Why? Because wherever the current flow increases, the voltage increases, the current flow also increases. Due to that, brightness of the bulb also increases. Means voltage is directly proportional to current. Yes or no? Voltage is according to Ohm's law. When you increase the battery source, for example, the small battery has millivolts, right? Right, like that. The big battery has 9 volt, and when you go for if you when you increase the size of the battery, the voltage of the battery also increases. When voltage increases, the current through the circuit also increases. Means voltage is directly proportional to current. When voltage value increases, current value also increases. Now you see, the in this way, in this question, the potential difference between the terminals of an electric heater is how much? They given 60 volt. Initial voltage is how much? 60 volt. And when it draws a current of 4 amperes, when voltage is 60 volt, then current value is how much? 4 ampere. Okay. Now, what current will the heater draw if the potential difference is increases to 120 volt? When voltage increases to 120, then what is the value of the current? Can you guess? Here voltage increases to how many times? 2 times. Okay. Voltage is directly proportional to current. Yes or no? When voltage value increases, current value also increases or not? Okay. And now you see, when the voltage is 60, the current value is 4. Right? Now your voltage increases to how many times? 2 times. Okay. Now you guess the current value, how much it is? Anyone can say, no problem. Yes. Yes. What is the current value? Very good. This is 8 amperes. Right? Simple. It is very simple. When voltage value increases to 2 times, the current value also increases to 2 times. When battery voltage is 60 volt, the source voltage is 60. When there is a current 4 ampere. Okay. Whenever the voltage value is 120, then what is the current value? It is also increases to 2 times. 4 into 2 is 8 amperes. Okay. In this way also we can do, according to Ohm's law, V is directly proportional to I. V by I equal to R. So it is a one way to guess the answer, but actual way it is not correct. But how to do this question? So initially, what is the voltage it is? Voltage is directly proportional to current, and voltage equal to, already know that V equal to IR, then R equal to V by I. Okay. Initially, the voltage value is how much? 60. Then voltage value is 60. Then what is the current value? 4. Okay. 60 by 4 means that material has the resistance value is how much? 15 ohms. Okay. The material has a resistance value. Resistance is a proportionality constant, right? It is always shows the constant value. Okay. Now, in the second case, what happens? The if voltage increases to 120 volts, if voltage increases to 120 volts, so in this case, what current will the heater draw? You have to find out, right? In the same material we are using, right? Same electric terminals, same electric heater we are using. The same electric heater, once we connected with the 60 volt source, and next time in the next situation we connected with the 120 volt source. When you connected electric heater to the 60 volt source, let us assume this is the electric heater, right? This is the electric heater. Okay, you connected to how much source it is? 60 volt source, right? 60 volt source. When you connected to 60 volt source, how much current is flowing through this heater? 4 amperes current is flowing through this heater. The same electric heater, when you connected to which source it is? 120 volt source. Means source capacity becomes double. Then current value also becomes double. Now, how much current flows through it? Yes, 60 becomes 2 times. 60 into 2 is 120. That 4 ampere of current becomes 8 ampere. Yes or no? To find this, we have another method, but resistance of electric heater is always constant. How much the resistance electric heater is? 15 ohm. Now you have to calculate the current value. Okay, then how do you find this current value? By using the same formula. I equal to V equal to IR means I equal to what? V by R. Now voltage source is different now. What is the voltage sources we applied here? 120 volt. And what is the resistance value of electric heater now? 15. Okay. Now use the 5 table. 5 how many times? Or 3 table. 3 5 are 15, 3 4 are 12, and it is 0. 5 how many times? 5 8 times. 540. 8 amperes. Now what is the current value? 8 ampere. So in this way also we can do. Simply we can assume that when voltage increases to 2 times, current value also increases to 2 times, and voltage and current both related to each other. When voltage increases, current value also increases. Simply we can say that when voltage increases to 2 times, current value also increases 2 times. Voltage increases to 60 to 120 means 2 times it increases. Current value also increases to 4 to 8 amperes. Is it clear? But for to find this, first you find the resistance value and use this resistance value here when source is increases to 120 volt. Then the current value is how much here? 8 ampere. So in this way we can do. Now here one more in-text question we have here. Okay. Now see this. Resistance of metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal at the temperature using table? Just now we discussed the table. The table has resistivity values for conductors, alloys, and insulator. By using the table, and this value is matching with which material? Just find out that material. Okay. Then how do you do this? Now you read the question. Resistance of metal wire of length is how much? What is the length of the metal wire given here? Already they said that this is a metal, right? It is not alloy. So length is 1 meter. Okay. And what is the resistance of that metal wire? That is 26 ohm. Resistance is how much here? 26 ohm, right? So if the diameter of the wire, diameter means D. So you have to find the radius, right? So diameter equal to 0.3 millimeter. Can I write 1 millimeter equal to how many meters? Yes, 1 millimeter equal to 10 to the power of minus 3 meters. Yes or no? So 0.3. So this we can write as 0.3 into 10 to the power of minus 3 meter. Okay. Can I write this 3 into 10 power minus 4 meter? Yes or no? Then diameter is 3 into 10 to the power of minus 4 meter. Then how do you find the area? Area. So resistance depends on two things, right? One is length and other one is area. Just now we discussed the formula also. Yes or no? Now you see, everyone please look at here. So we need area. For area, what is the metallic wire? Area. Area means this metallic conductor has some area, right? So that is pi r square. That you have to find the radius of the metallic wire, right? Radius equal to diameter by 2. Already you know that. So radius equal to diameter by 2. So that this is equal to 3 by 2 into 10 to the power of minus 4. How much it is? 3 into 10 power minus 4 by 2. Okay, 3 by 2 is how much? That is 1.5. Yeah, otherwise you keep it like that only, no problem. Okay, then area. Then how do you find the area? So area is, so what is the area value? Area equal to pi r square. Yes or no? Area equal to pi r square. And just you write here itself. Area equal to pi into r square. Pi means 22 by 7. Radius square. Radius square means 3 by 2 into 3 by 2, 10 power minus 4 into 10 power minus 4. R square is there. 3 by 2 into 3 by 2 is 9 by 4 into 10 power minus 4 into 10 power minus 4 is 10 to the power of minus 8, and this is a area in meter square, right? Now what you have to find out here? What you have to find out? You have to find out the resistivity value. Do you know the formula of the resistivity? So you have to find the resistivity value. Then how do you find this resistivity? We have the formula R equal to rho into A by L. Then you have to find the rho. Then rho we can write as, sorry, rho into L by A. R is directly proportional length, inversely proportional to area, right? Then from this you have to find the rho value. Rho equal to R A by L. Okay, just you substitute the value here and find out the resisted value. Just pause the video and do it. Okay, just you substitute the value here. Just all of you please do it. Right, now you see what is R value? 26, right? What is the area of the metallic conductor? That is 22 by 7 into 9 by 4 into 10 to the power of minus 8, and length of the wire is 1 meter. So by 1, no need to take, by 1 is same value it will come. Okay, so when you do this you will get one value, and this value matching with the table value. Okay, just you compare which material has this value. Now you see, just you do the simple calculation first. So this is 4, right? So how many times 2 2 ja 4 and 2 11 times. Here we have 2 1 ja 2 2 13 times, right? Here we have 13 into 11 into 9, 13 into 11 into 9. So this we can write as 13 into 99. Okay, so now you do 13 into 99 is how much? Yes, 3 9 are 27. 2. 3 9 are 27 plus 2. Yes, how much? 27 plus 2 is 29. So similarly, uh, 99 into 1 is 99. Right? Just 7. 9 plus 9, 18. 10, 12. 1287. 1287 by 7 into 10 power minus 8. Okay, now you just divide with the 7. Just you divide with the 7. How much you will get? Just you check the answer here. How much you will get here? 1287 by 7. You see, I am doing here 1287 by 7. 7 how many times? 7. 12 minus 7 is how much? 5. 58. So 7 how many times now? 8 times. This is 56. Yeah, 27 is coming. So 27 means 7 3 ja 21, 7 4 ja 28. It is nearly equal to 7 4 ja 28. So I am taking nearly approximately value 28. So it is equal to 18.39, like that it will come, right? So 184. So approximately I am taking this value 184 into 10 to the power of minus 8, right? So just you adjust into two decimal. Okay, then what you have to do here? So you do here by 100 into 100 you do. Okay, 184 by 100 is how much? That is equal to 1.84 into 10 power minus 8 into 100 is how much? 10 to the power of minus 6 ohm meter. Now you check the value, and this value is matching with which material? Yes, check this answer. This value is matching with here 1. You see exactly it is matching with 1.84 into 10 to the power of minus 6, and this value is matching with the manganese. Yes or no? And now we can confirm that, and the material is what here? What is the material? That is manganese. Okay, so now we can confirm here. Now you see, now we have to using the table 12.2 the predict the material, and this resistivity value is matching with the manganese, and this is the manganese. Okay, by seeing that table we can confirm that 1.84 into 10 power minus 6 ohm meter is matching with the manganese material. Is it clear? So in this way you have to solve this question. It's a very important. So many times in the board exam they have asked, right? Next question, right? So now you see here, in example, now it is 11.6, right? A wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having L by 2 and area of cross section 2A? Oh, have you understood this? Now you see, a wire of given material having length how much? What is the length? Length value is how much? Length value is L. Cross section area, that is A, and has a resistance value how much? 4 ohm. Okay, the material has length L and area A, and having the resistance value is how much? 4 ohm. Okay, the original wire you have taken. Now what happened here? What would be the resistance of the wire of the same material having length L by 2 and area of the cross section 2A? Means, so you're taking one wire here. Let us say, just a minute. So this is a wire. Okay, this is a wire. This is having some length L, right? So what we are doing, I am making this L by 2. Okay, L by 2. Now you see, when length is by 2, area becomes how much now? 2 times. Okay, the length become L by 2, area become 2A. Then if area increases, already know that area is inversely proportional to resistance. Yes or no? When area increases to 2 times, length decreases to 2 times, then resistance increases to decreases to how many times? Resistance decreases. Why? Because area increases. Area increases, resistance value decreases. Then how it will decrease? Let us see now. uh, how much it will decrease. Okay, let us find out this. So what is the resistance value? Resistance equal to rho into L by A. Let us say this is equation 1. Okay, now what are the changes taken place here? Yes, what are the changes taken place here? Yes, that resistance, the length becomes half, means let us say L dash becomes L by 2, right? Then area become 2 times. Okay, then let us say the new area becomes 2 times of old area, right? 2a. Then what would be the new resistance? Okay, then find out this. But we are using the same material. Okay, in this case we are using the same material, we are not changing the wire, right? We are using the same wire. So what happens, the length become half, then area become 2 times. Then what would be the resistance, and how much it will decrease, right? Now you see, then how to calculate this, let us see. Now you see, use the same formula, R dash equal to rho into L dash by A dash. Okay. Now you substitute the values here. Length becomes how many times? L by 2 times, right? Just you put the value here, L by 2, right? Area become how many times? 2 times. 2A. Area becomes 2A. Then what would be the new resistance? Now you see, rho into L by 2. By 2 come to the denominator. 2 into 2 is how much? 4. 4A. And this rho L by A. Can I replace this rho L by A with R? Yes or no? Can I replace this rho L by A with R? Then this will become R by 4. The new resistance, it is decreases to how many times? 4 times with old resistance. What is the value of old resistance? Given it is, that is 4 ohm, right? So you substitute your 4 by 4 is how much? 1. The new resistance becomes how many times now? By 4 times, which is equal to how much now? 1 ohm. When length is L, cross section area is A, then the resistance by resistance is how much? 4 ohm. When length decreases to half, area becomes 2 times. In that case, resistance decreased by how many times? 4 times. Area increases, resistance value decreases by 4 times, right? 4 by 4 is 1 ohm. So in this way you have to do this. Is it clear, everyone? Okay, shall I move? Yes. Now you see, on what factor, these are the in-text questions, okay, from 10th class. On what factors does the resistance of a conductor depends? Already we discussed resistance depends on 3 factors, right? What is that? Length. When length increases, resistance value also increases. When area increases, the flow of electron, the speed of flow of electron increases. If electrons flow increases, current value increases, resistance value decreases. Means resistance depends on length, cross area of cross section of the conductor, and also it depends on nature of the material. Okay, conductor has some resistance value, insulator or another, like poor conductors, good conductors. Okay, it depends on nature of the material also. Okay, now in question 2 they are asked for, will current flow more easily through a thick wire or thin wire of the same material when connected to the same source? Already we discussed, just now we discussed. Thick wire means has more area, thin wire has less area. Now you tell, in which wire the current is more, the current value is more. Yes, very good. The material which thick has more area, the more area conductor has more current value. Why? Because the flow of electron, the speed of flow of electron is very fast. The material with more area. For thin area having material, let us say this is a thin area, it's a very thin area, so very narrow road. Okay, the speed of electron somewhat it is reduced. It is a highway. In highway, the speed of electron is very fast. That means the current value is more. If current is more, resistance is less. Resistance means if there are any speed breakers in between the road, our speed reduces. Our speed is resisted by the speed breakers. Okay, suppose if the road condition is not good and this is thin, very thin, means here wire you compare with the road. So here wire made with very thin means the area is very less, very narrow road. The flow of electron is very less. This means the flow of electrons slow down, right? If flow of electron is less, that means it has less current, more resistance. Yes or no? Now the answer is the current will flow more easily through a thick wire. Why? Because it has more area, right? Than thin air wire of the same material. Larger the area of cross section of a conductor, more is the easy which the electrons can move through the conductor. Therefore, smaller is the resistance of the conductor. If area is more, current is more, resistance is less. If area is less, the flow speed of electrons move very slow. That means the current is less. If current is less, resistance is more. Means from this we can say that simply the thick wire has low resistance value than thin wire. Okay, shall I move? Yes. Now you see in this slide, the question number 3 in text question. Let the resistance of an electrical component remains constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? So just you try to understand the question. Let the resistance of electrical component remains constant, but here resistance is not changing, resistance value is constant, right? While the potential difference across the two ends of the component decreases to half. Already we discussed, according to Ohm's law, potential difference across two ends of the conductor. Suppose let us say this is a conductor, it has A and B, right? Charge flows from high potential value to low potential, and the difference between the ends of the conductor voltage is how much? Let us say that is V. When V become V by 2, okay, well, the potential difference across the two ends of the component decreases to half of its former value. Means voltage decreases to V by 2. What change will be occur in the current through it? Can you guess? When voltage decreases to by 2 times, current also decreases to by 2 times. Current also becomes half value according to Ohm's law. When voltage increases, current value also increases. When voltage decreases, current value also decreases. When voltage becomes to by half, and current value also becomes half. Yes or no? Now the answer is when potential difference is off, the current through the component also decreases to half of its initial value. So this is according to Ohm's law. That is V proportional to I. So when V increases, current increases. When V decreases, current value also decreases. Clear? Move on to the next question. Okay. So now we have your why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? Already we discussed, right? Pure metal has low resistivity value, acts as a good conductors. When this metal is mixed with another metal, so it will give alloy. So alloy has more resistivity value, which leads to heating elements, right? And means the materials which has a high resistivity value acts as a good heating elements, which are used in heating devices, right? The coils of electric toaster, electric irons, and other heating devices are made of an alloy rather than a pure metal because the resistivity of alloy is much higher than that of pure metal. It's a very important question. So many times in the board exam they given. So an alloy does not undergo oxidation and they do not burn easily even at high temperature when it is red hot. Even wherever the high temperature condition, and they do not get burned. Alloy do not get burned even at high temperature, and alloys has more resistivity value. Because of these two reasons, alloys used as heating elements in heating devices. Okay, shall I move? Yes. Now you see, use the table, that the same table just now we have seen, right? Which among the iron and mercury is a better conductor? Which material is the best conductor? Now you have given these values from the table. I have taken the values from that table. So resistivity to iron is 10 into 10 power minus 8 ohm meter. Resistivity of mercury is 94 into 10 power minus 8 ohm meter. So based on these two values, which has a more resistivity value? Mercury. And which has the low resistivity value? Iron. Now you tell which acts as a good conductor? Yes? Anyone? Which acts as a good conductor? Yes? Yes. Iron acts as a good conductor. Why? Because it has a low resistivity value. Right? Thus iron is better conductor because it has low resistivity than mercury. Now They have asked for which material is the best conductor. Already we discussed. Among given all metals, silver has low resistivity value. It acts as good conductor. Now you see silver. Silver has the low resistivity value. How much it is? 1.6 into 10 power minus 8 ohm meter. Okay. Therefore, silver is the best conductor. Is it clear, everyone? Okay. So now the resistors in series and resistors in parallel. Okay. So this is resistors when you connect it in the series, what happens? Resistors when you connect it in the parallel, what happens? Let's everyone please look at here. Just a minute. So now you see some resistors. Resistors means you suppose you are using bulbs, right? Or any fan, any devices, right? Like this, any devices, fan or electric bulb, electric heater. When you connect it like this in series, in same wire connection, okay? Suppose you are giving the same source, and what is the source in our home? 220 volt source. What is the battery source? Our car batteries. That is how much? 12 volt. 12 volt battery it is. Now assume that is by using the 12 volt battery, we can run the AC, we can run the headlights, we can run the whatever the things in there in the car, speakers, right? Uh, these all these electrical components depends on the 12 volt battery. But in our home, how much power is there? How much source is supplied by the electricity department? That is supplied 220 volt. It acts as a 220 volt battery. Okay. Suppose all this you connected with the 220 volt battery. Then what happens when you these devices when you connected in the series? Okay, what happens? Suppose already you observed that decorative decorative lights has a series connection. Have you observed this? Decorative lights, these are connected with the only same wire, right? These all are having series in connection. Okay, we can see the series connection in the decorative lights, right? So in the same way, you are connecting all components has some resistance value which are used by one symbol. Resistance is used by this symbol. These are the speed breakers, right? What is speed breaker indicates? Wherever the speed breaker comes, the flow of the speed of electrons somewhat reduced, right? So here we have some speed breakers, means some resistance values. Let us say we have here, let us say this is resistor value R1 and this is R2 and this is R3, right? And these all resistors are connected to the same source. That is these are the cell. Okay, this is a plus terminal of the battery and this is a negative terminal of the battery. Already we discussed it in the 7th class also. This is right. Now this is like this. The battery is a combination of two or more cells, and the longer the line indicates the positive terminal, shorter the line indicates the negative terminal. And remember, current flows always from the positive terminal to negative terminal, and electrons flows from opposite to the current direction. Okay, current flows like this. Okay, but here wire is same. That means your current is same, but voltage is not same. Okay, for R1 resistor voltage drop is V1, for R2 resistor voltage drop is V2, for R3 resistor voltage drop is V3. Okay, the voltmeter we connected in parallel, right? The voltage drop across R1 resistor is V1, the voltage drop across R2 resistor is V2, voltage drop across R3 resistor is V3. Let us assume the battery voltage is 12 volt. Everyone please assume that the battery voltage is 12 volt. Suppose this assume as is a bulb. So bulb is taking the voltage drop is 2 volts, right? So here you assume that here geyser is there, electric geyser. Okay, electric geyser means let us say it wants more current, means it consume more voltage, right? So let us say it consumed 10 or let us say it consumes 9 voltage. So 9 plus 2, how much it is? Okay, 11. So let us say it is a bed light or zero light lamp. So it consumed 1 volt. So now you see, when you combine all these voltage drops, which is equal to how much here? That is the battery voltage. It is equal to the sum of the battery voltage, that is 12 volt. Now you see 2 plus 9, how much? 11. 11 plus 1, 12 volt. Means in series voltage is not same, but current value is same. Remember, in series which is not same, voltage is not same. For every resistor there is somewhat voltage drop is there. Okay, when you combine all these values, you will get the net value of the battery, that is 12 volt. Means here V is equal to V1 plus V2 plus V3. Okay, when you combine all this, it is equal to the combination of all voltage drop is, it will give the equal to the battery voltage, 12 volt battery voltage. Now you see, according to Ohm's law, here what is the same value? Current is same. Current through R1 resistor, current through R2 resistor, current through R3 resistor. Everywhere the resistor value is same. Okay, sorry, current value is same. Okay, but voltage value is not same in series, right? So now according to Ohm's law, already you know that voltage V equal to I into R. Then V1 equal to, so how much current is flowing through this? I current through R1 resistor. Then V1 drop is how much here? V1 equal to I into R1. Then what is the V2 value? Can you guess? V2 equal to I into R2. Okay. So V2 voltage equal to how much? It is equal to I into R2. Then V3 equal to how much current is flowing through this resistor? Same I current is flowing through this resistor. Then V3 equal to how much? V3 equal to I into R3. When you combine all this, and also just you substitute here, just you substitute these values here, then what will you get here? IR equal to I R1 plus I R2 plus I R3. So take I common here, take I common, that is R1 plus R2 plus R3. So I get cancelled, right? Then what will you get here? Finally we will get this. So when you connect resistors in series, then total resistance is equal to sum of all individual resistance values. Okay, then R equal to R1 plus R2 plus R3. It's a very important formula, right? We used in many applications also this formula. So very important. The derivation also very important. And just remember in series which one is same and which one is not same, and how we derive this formula. Resistance equal to R1 plus R2 plus R3. Okay, remember. And this is a formula for the series connection. Now you see, this is resistor in series. When two or more resistors are connected end to end, the arrangement is called as series connection. So current through each resistor value is how much here? Same. But the total voltage equal to sum of voltage drops. V equal to V1 plus V2 plus V3. According to Ohm's law, we know that V equal to IR. So V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. When you substitute all this, you will get the final equation here. R equal to R1 plus R2 plus R3. Okay, you have to connect like this. R1, R2, R3, right? Here switch key is there, it is ammeter is there which measures the electric current value, and this is a voltmeter is there, so which measure the voltage drop across each resistor. Okay, so when several resistors are joined in series, the resistance of the combination is Rs, and which is equal to sum of their individual resistance R1, R2, R3, and thus greater than the individual resistance. The total resistance of the circuit is greater than the individual resistance. Why? Because we are combining all resistance. Yes or no? Okay, and move on to the next one. Here we have one problem, right? Now you see, this is your example problem. This is 12.7 and now it is 11.7. An electric lamp whose resistance is 20 ohm. And what is the lamp resistance value? How much it is the given? That is 20 ohm. How much it is? 20 ohm. Remember, this is 20 ohm. Okay. Now which is connected with the other resistor with series, that is having resistance value 4 ohm, right? And which is connected to the battery. What is the battery source they given here? This is 6 volt battery, which is connected to the ammeter which measures the electric current, and here switch key is there, where when you put the dot means the current is flowing through this circuit, right? Now we have to find the total resistance value. You have to find, right? How do you find the total resistance? When you combine the individual resistance, you will get the total resistance. Yes or no? Suppose here we have the resistance series in combination. When you add these 4 plus 20, 4 plus 20 is how much? That is 24 ohm. And this is a total resistance of the circuit. Okay, when you combine these 4 ohm plus 20 ohm, what is the total resistance value in the circuit? That is equal to 24 ohm. Okay, and the current through the circuit is how much? Okay, how do you find the current? You know the resistor total resistance value, and this is connected with the which battery? 6 volt battery. Then how do you find the current value? We have a formula, I equal to V by total resistance, Rs. And what is the battery source? We connected with the 6 volt battery. Battery source is 6 volt. And what is the total resistance? 24. 6 by 24 is how much? That is 1 by 4, which is equal to how much? 0.24 0.25 ampere. So this much current is flowing through this circuit. How much current is flowing through this? How much current is flowing through this? That is 0.25 ampere is flowing through the 4 ohm resistor, and the same current is flows through this bulb also. How much it is? 0.25 ampere, right? And one more is there. So what is potential difference across each electric lamp and conductor? Okay, you have to find the voltage drop. Voltage drop, how do you find? We have this the connection voltage drop. How do you find? This is a V1, right? And let us say this is V2. Okay, then how do you find this voltage across the 4 ohm resistor? Voltage drop across the 20 ohm resistor. Okay, now you see how do you find this? V1 equal to how much current is flowing? I current is flowing, right? So I through the 4 ohm resistor. Okay, 4 ohm resistor. The resistor value is 4 ohm. Okay, and now how do you find this V1 value? So V1 equal to current into resistance value. Current value is how much? 0.25. Can I write as 1 by 4? Yes or no? Can I write 1 by 4? Current value is 1 by 4. What is the resistor value? Resistance value is how much? 4. 1 by 4 into 4 is how much? 4 cancel, which is equal to 1 volt. And what is the voltage drop across the 4 ohm resistor? 1 volt. Out of 6 volt, the droppage is 1 volt. The remaining will be how much? Out of 6, 1 volt drop here. The remaining voltage, how much drop here? Yes, can you guess? 6 minus 1, how much it is? 5. Let us see. We are getting 5 or not? Just check the answer. Okay, now voltage across the lamp, let us say that is V2. How much current? The same current is flowing. The how much resistor value is 20 ohm. Resistance value is 20 ohm. The current value take here 1 by 4, right? So 1 by 4 into resistor value is 20. 20 by 4 is how much? 5 volt. Okay. Now you see when you combine these two voltages, are you getting the total voltage value or not? Now you see, you check the value. V equal to V1 plus V2. V1 drop is how much? 1. V2 is how much? 5. 1 plus 5, 6 volt, which is equal to the battery voltage. Is it clear now? Yes or no? The voltage drop across 4 ohm resistor is 1 volt. The voltage drop across the lamp having 20 ohm resistor value is 5 volt. When you combine this 1 plus 5, and this is equal to 6 volt battery value, right? Yes or no? So in this way you have to solve this problem, right? So here we have one more problem. Can you draw this, right? Can you draw the, everyone please try this. Draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor, and 12 ohm resistor, and plug key all connected in the series. Okay, first you draw the schematic diagram of the resistor. Schematic circuit. So let us say you take circuit like this. Okay, here we have battery of 3 cells, right? Battery of 3 cells. How many are there? Battery of 3 cells. Each cell is having how much voltage? That is how much? That is 2 volt, right? Like that we have how many batteries are there here? 3 batteries, 3 cells are there. Each one is having how much voltage? 2 volt, 2 volt, 2 volt. Total it will be how much? 6 volt. Clear up to you? And each is having 2 volt, like that we have the 3 cells. Means total potential is 6 volt. And 5 ohm resistor is there. 5 ohm resistor, 8 ohm resistor, 12 ohm resistor. Okay, here we have the 3 resistors, right? So one is 5 ohm and the other one is, what is that? This is, let us say this is 5 ohm. Okay, and this is 8 ohm. Okay, 8 ohm, and one more resistor is there. This is 12 ohm. Okay, now and plug key all connected in the series. You put one plug key also, right? Plug key. So just you put the plug keys. Then what is the symbol of plug key? So you have to represent with bracket with dot. So this represents plug key. That switch, like it acts as switch. Switch off, switch on. Okay, when you switch on the battery, the current flows like this. Okay, how it will flow? The, yeah, this bigger line indicates positive terminal, the shorter line indicates negative terminal, and the current will flows from the positive terminal to negative terminal. Okay, like this it will flow. Okay, so in the next question, in the next question they have the are asked for the same diagram. You have to redraw the same diagram, and we need to find the what is the we have to find the yeah. So putting in an ammeter to measure the current through the resistor and a voltmeter to measure the potential difference across the 12 ohm resistor, what would be the readings in the ammeter and voltmeter? Now you see the same diagram, just you draw again here, just you draw. Okay, so which is connected to how much, that is 6 volt battery. Right here we have switch key and put one ammeter also. So ammeter measures the current, okay, through the resistor. So this is what is the value it is, that is 5 8 12. Okay, so let us say this is 5 ohm, 8 ohm, 12 ohm. Okay, so we need to find the current value, okay, by using the Ohm's law. Just pause the video and do it, right? Just all of you please try to solve this question. Yes, you also please find the resistor total resistance value, find out. Yes, do it. Total resistance value, find out. RS value you find out. Okay, then current value, how do you find out? What is the voltage, total voltage here? 6 volt. And find the current value, I equal to V by RS. This is the total, this is the current flows through the each resistor. And also you have to find the voltage drop across this 3 ohm resistor. Let us say this is a V3, and you find the voltage drop across this 12 ohm resistor after finding the I value. Okay, can you try this? Yes, just you follow this formula. Total resistance equal to sum of all individual resistance. Yes or no? Then this is equal to R1 plus R2 plus R3. So let us say this is R1. Okay, this is R2 and this is R3. Then RS equal to R1 plus R2 plus R3. Then how much it is? 5 plus 8 plus 12. 12 plus 8, 20. 20 plus 5 is 25 ohm. Okay, the total resistance value is how much? 25. Find the current value now. Then what is the voltage? 6 by 25. Then how do you find this? 6 by 25, you multiply with 4 by 4 to make denominator 100. I am doing like this. So 6 4 ja 24, 25 into 100 is 100. 25 by 100, how we can write? 0.24 ampere. So this is the current value which flows through this circuit. Okay, so but remember in series the current value is same. Okay, so current through 5 ohm resistor, current through 8 ohm resistor, current through 12 ohm resistor, it is same. How much it is? 0.24 ampere. They have asked for what is the current through 12 ohm resistor. The current through 12 ohm resistor and 5 8 and in total circuit the current value is same, that is how much? 0.24 amperes. Now we need to find the voltage drop. Voltage drop across 12 ohm resistor, we assumed here V3. V3 equal to current into R3. Okay, so what is the voltage drop across 12 ohm resistor? What is the current value we just now we got here? Yes, that is 0.24 0.24 ampere. And what is the resistor value? This is a 12 ohm resistor. 0.24 into 12. 12 4 ja 48, 12 2 ja 24 plus 4. How much it is? After two digits you put the point, that is equal to 2.88 volt. So what is the potential drop across the 12 ohm resistor? 2.88 volt. Can you find the voltage drop across? They have not asked just now. Just you find out v2 also you find out. V2 equal to same value. V2, how do you find out? V2 equal to same current 0.24 flows through the 8 ohm resistor. Okay, V equal to IR. 8 4 ja how much? 8 4 ja 32, carrying 3, 8 2 ja 16, 17, 18, 19. After two digits you put the point. This is 1.92 volt. How much it is? This V2 equal to 1.92 volt. Similarly you find the V1 also. How do you find the V1? V1 equal to the current value is always same, 0.24 across 5 ohm resistor into 5. 5 4 ja 20, 5 2 ja 10 plus 2. Okay, how much it is? 1.2 volts. Okay, just you combine. Are you getting 6 volt or not? Just you check here. Combine all these value. 1.2 plus 1.92 plus 2.88. How much you are getting? Just you check here. 8 plus 2 10, right? So 0. 10 means 9. 18. How much it is? uh yeah, just you check it is how much it is coming. You have to get here 6 volt battery. 6 volt. It is equal to 6 volt or not? Yes or no? Just you check. It is equal to 6 volt. It will come as 6 volt. Okay. Just you check this. Yeah. It is equal to 6 volt. Yes or no? Yeah. In this way, you have to solve the problem. Okay.